So now that we have an idea of what an antiderivative is, we're just going to introduce some new notation just to kind of say, do the antiderivative, and so we can reference it easier, just like we do with the derivative. We use that little prime notation. And the notation we're going to use for antiderivatives is called the integrand. All right, you're going to be taking integrals using the integrand. All right, and it's this kind of curly thing. All right, when I draw it by hand, it looks like that. It's kind of an elongated S. And then here's how it relates to antiderivatives. So I want to take the indefinite integral. All right, that's what this symbol means. I'm taking the integral of the function lowercase f. All right, this thing at the end, this dx. It looks confusing, but basically this is just saying your variable is x. So this dx part is just important so we know what variable we care about in our expression. All right, and that'll pretty much be there every single time you're talking about integrals. All right, but if I want to do the integral of f of x, that's basically just saying take the antiderivative of it. All right, so this symbol for now, you just think about saying it means take the antiderivative. And of course, we always add this plus c because we don't know what that constant could have been. All right, some other things with integrals. All right, just like with derivatives are really nice with addition and subtraction, and constants. Integrals are going to work the same way because they're just related to derivatives. So if I add or subtract inside of this integral, I can break it up into two separate integrals and just add and subtract between them. And this is going to be easier because I can just find these simple antiderivatives instead of finding one big antiderivative all at once. And of course, I'll have this plus c. Also, if I have just some constant multiplying by my function, I would know constants come out of derivatives, so they're also going to end up coming outside of integrals as well. All right, so just like we can with derivatives, we can break it up into smaller pieces. If we have some constant multiplication, or you can pull those out to make your problem simpler. All right, so that's this new notation, all right, this kind of curly S integral. Basically just means take the antiderivative. So we're just making sure that whatever we write this antiderivative is equal to, if we took the derivative of it, we'd get back to that function in there.